Okay, so let's get started. This session is being recorded. A copy of the session will be made available for everybody that registered. We will also send out not just the recording, but also the slides as well. So once again, welcome. My name is Vishal Prakash. I am the product manager at ProSoft for our industrial remote connectivity and IIoT solution portfolio. I'm also the product manager for many of our protocols, especially SCADA and telemetry protocols, which is one of the solutions that we'll be talking about today. So today's session is all about missing data from remote assets. If you're missing data, how can we solve that problem? And that's what we're going to be talking about. Let me turn on my laser pointer so it's easier to see. Okay, so the missing data part really only applies a lot of it to critical infrastructure. And the reason why is because these services, especially any kind of critical infrastructure services, are geographically dispersed. And whether you take services like water or wastewater, whether you take its power or gas, these systems are quite well distributed. So getting data back, or if you're missing data from these systems, then the ability to operate these systems efficiently and productively diminishes. And given how critical this is, it's a continuous service, it's a service that's highly regulated. Clearly, there's safety components involved to it, not just safety from an automation standpoint and how the system operates, but safety in terms of the service being provided. So it's for these reasons why these are critical infrastructure, and therefore it's absolutely important to ensure that data from these remote sites are always available, it's reliable, and that data is there when you need it. So ensuring the accuracy of that data and ensuring that that data is being collected reliably is something that's very, very important. What we'll be doing in today's session is looking at ProSoft's solution to address that problem, that data reliability and that security of data coming in from the remote sites. So before we do get started, just a very, very quick overview of who ProSoft is. For those of you who don't know, ProSoft has been around for well over 30 years, and we really are your industrial connectivity experts. Whether you're looking for solutions to connect dissimilar equipment within a factory floor, or if you're looking to connect machines reliably globally, ProSoft is pretty much a solution. We also enable reliable connections, whether it's newer protocols like OPC UA and MQTT, or many of the older legacy protocols as well. ProSoft is application oriented with both on-site and off-site technical expertise that will help you solve your most challenging communication problems. So let's get started. And I'd like to get started with this slide. What we are talking about today, like I said, critical infrastructure and missing data from remote sites really applies to utilities, because if you take the plant floor, if you take a machine, a factory, most of your assets are generally connected. And if they're not, then when they're geographically dispersed, if you take a factory floor, for example, you might have some assets that are on the outer layer, but the distance between them and the factory is not too great, where you can get some fairly easily, you can get wireless connectivity. Utilities, on the other hand, they're geographically dispersed, and you take countries like Australia or the United States, where these are really vast countries. For example, I think some of you know that Australia has got the world's longest milk run, for example. So we are not talking small distances. So when you've got these assets spread over a really, really large area, it's really important to ensure that they're functioning correctly, because when utilities function correctly, societies function normally. And it really is the fundamental to any society's progression. Without functioning utilities, you would not see the growth in the megacities we have today. Whether you talk Singapore, whether you talk Sydney or Dubai, the growth of these cities are fueled by functioning utilities. Innovation and the growth in urbanization and any of these things, these are only possible if you've got functioning utilities. And utilities, like I said, I keep going back to that these are geographically dispersed. So the operation of these utilities that need to be both reliable and productive is extremely important. And the problems that these utilities are facing, because remember, utilities it's a continuous service. It's highly regulated from from a safety perspective. And they're stressed because there's this continuous growth, this explosion. I've read statistics, for example, in some countries, millions of people, because of the growth of urbanization, are expected to be connected to these utilities just over the next few years. So these utilities sort of face a lot of stress. And as they continue to expand, as they continue to operate, they face some issues that affect the reliability in the operation of the services. So to help them solve those problems is what we're talking about today. And here's a summary of some of the problems. They're not all the problems, but these are summary, sort of a high level overview of some of the problems. So if I was to go through as an example, for example, it is very important to know what happened when and at what time, because if you don't know when exactly something happened, the root cause analysis for that problem is not going to be very efficient, because typically, at least in industrial operations or industrial applications, one fault could lead to another problem. Or by knowing the order of that problem, you're able to do pretty extensive predictive maintenance or understand the diagnostics to ensure that issue does not happen again. So the ability to know what happened when and at what time is very, very important. And you can sort of go through the rest of the problems that I got listed there. So yeah, how do we address these problems? What is a solution to these problems that we're talking about? Because remember, fundamentally, even if I was to break these problems down further, we're talking about data reliability, data security in the operation of remote assets, geographically dispersed remote assets in utilities. And that could be water, wastewater, could be oil and gas, it could be power, could be gas distribution. So the solution is actually a protocol, and that protocol is DNP, or Distributed Network Protocol. So the solution from ProSoft uses this protocol to address the problems that we just looked at. And the reason why DNP3 works as a solution is because of some of those features that I've listed. One of the biggest advantages of this protocol is that it's highly scalable. You could have thousands of devices on a single network. In fact, the protocol allows for up to 65,535 devices. And when you say devices, that could just be a location in that system. Now, clearly, in a practical system, you're not going to have one with 65,535 assets, but it tells you about the scalability of the solution, that you're not limited to small systems or where you don't have to create clusters and so forth. The other big advantage of this protocol is that it's an open standard. So it is not tied to any particular vendor. It is not tied to any particular product as such. This standard, the people that maintain this protocol and the standard, they are completely vendor neutral. So they come together and they've created this protocol that really is open. And we're going to see what that open protocol means later on. How do you comply with that? Some of the other features of this, secure authentication, which are great advantage of that. And we're going to talk about the difference between authentication and encryption. But authentication allows you to run on any network. So for customers that have got an existing network, whether it's a water system, whether it's an oil and gas system, so let's say if you've got a radio network, you can still take advantage of authentication to ensure that end-to-end authentication. And we support the highest level of authentication in the ProSoft DNP3 solution. So just very quickly on the history, and I'm not going to go through all of this in detail, but fundamentally the protocol was originally developed by a company called Westronix. They were out of Canada. GE eventually bought them, and this was in the late 80s. And then in 1993, the protocol became an open protocol, which is being managed by the DNP3 user group. It is a community that evaluates a protocol to make sure that it continues to stay relevant, it continues to stay open, and they're continually adding and enhancing the protocol from a functionality perspective, but also from a security perspective, given how important that is in today's environment. It's a very widely used protocol. It's been around, like I said, for well over 20 years. It is based on a standard. That standard actually helps with the NIST-CERC compliance as well. I told you how scalable it is. The other advantages of this protocol is it does include a fair bit of diagnostics, which all of the diagnostics, the biggest use for that is it comes in and helping with things like predictive maintenance. One of the biggest things with this is it's a timestamped protocol. So any event, any alarm condition that happens, you've got a time and a date stamp, and all of that information can then be brought back to a SCADA host for analysis. And this would help with things like scheduled maintenance, planning downtimes, reducing the mean time to repair, and with predictive maintenance as well. The protocol allows users to classify data, and the reason you can do that is because this is a push and a pull protocol. So what I mean by that is where you can have outstations that have the ability to send data when there is an alarm. And typically in many of the older systems, and especially in Modbus, for example, it's a poll-only system. So it is continuously going around asking for, give me your data, give me your data, give me your data. And that might work if you've got a small system, but if you've got a large system, that's not a very efficient use. You'll start to miss a lot of data. So by having the push and the pull, you can go and say, are you okay once a day or once a couple of hours, and then allow for the remote sites to send through an alarm when there is an issue. And that ensures that alarms get shown at the top end or are seen at the top end very quickly, which means you can act on it. And there's an example. We're going to go through that later on in this presentation. These are some of the most common DNP3 terms you're going to come across. DNP3 stands for distributed network we'll go for. The next one is very important, the DNP3 device profile document. This is basically, it's like a characteristics document, and it's what users need to check the compatibility. So think about the device profile document listing every single feature that this product or any product, DNP3 product should support, excuse me, in detail. And that detail is extremely important because that allows you to test the compatibility of the system, or the compatibility of the solution with the top end. The other one, you've got the master and an outstation, which is typically the remote device. The static data in DNP3 stands for the current value, whereas event data is time-stamped. And then you've got the data classification. And today, DNP3 supports 4 classes of data. Class 0, which is static, and then class 1, 2, and 3, which is event-based. We're going to go through that as well. And then we're going to go through an example of a unsolicited response and an integrity poll, so you'll understand what the difference between the two is. I just mentioned about the device profile document. I said this is the characteristics document. This tells you everything that the product can do or won't do. This is sort of that interoperability guide that allows users to check, especially if customers have got an existing system. Remember, one of the things I said, that DNP3 is an open protocol. That's a big advantage for an end customer, because what it allows them to be is completely vendor neutral. So if you've got a customer, so let's say, for example, it's Hong Kong Water, and today they've decided they're using the ProSoft DNP3 solution, but they're not happy with us, or it does not support a certain function, they can go somewhere else, make sure that they use they check the compatibility of the other solution, and if it works for them, they can put it in the same system and not have to change their top end. So you could have one top end and you could have 5 or 6 different types of remote solutions. Obviously, that works in ProSoft's advantage as well, where if you've got an existing DNP3 customer that's got a solution, but they're not very happy with it or it does not support certain features, then they can look at the profile document of the ProSoft product and see, does it comply or does it help with the features that they're looking for? And if it does, then they can continue to use a solution without having to change the top end, without having to relearn a brand new protocol, without having to relearn a new solution, because there is a lot of similarities in sort of the protocol and the data structure that allows them to implement the solution very quickly and easily. So here's a more detailed explanation of what static data means. Remember, I said static is the current value of all of the points configured in the DNP3 register map. With DNP3, a register is actually called an object. So there are objects of different types. There are binary inputs, which is digitals. There are binary outputs, which is digital outputs, analog ins, and there are different types of analogs and 16-bit analogs and 32-bit analogs. But you've got all of these different objects, and you can say an object is a class 0 type of DNP3 point, and that basically means then that you're only going to get the real-time value of that. Same thing if you say, the tank level, which might be an analog input object number 1, if you say that that's a class 1, 2, or 3 type event, then you can log every time there's a change to that value, and that change could be driven either by a deadband, it could be driven by time, but fundamentally what you're recording is when there's a change, you're recording that with a date and a timestamp that allows you to retrieve that information and analyze it. And let's say if you lose communication to the site, then if you've got these as timestamped events, it's going to continue recording that data. When your system recovers, you're going to get all of that data back and backfill, which is why we say with DNP3, you don't have any holes in your data. So what I mean by that is that typically if you use protocols like Modbus, when you lose communications, you lose data. All you're going to see is like a flat line. With DNP3, because of the timestamping, it records all of that data, and then you can get it back up to the top end. That will allow you to analyze and get a more accurate picture of what happened. So, for example, if the tank level dipped down to less than 10%, during that comms failure, you'll be able to see that. And you'll be able to see if the system worked as it should, and the pumps ran to fill up the tank level again to make sure it is full, ensuring that the town does not run out of water. These are some of the different object types that DNP3 supports, set various types. And again, the advantage with all of that is you can take a simple variable, whether it's pressure or temperature, and you can do some additional diagnostics with it. And if you want to freeze the value or you want to convert it to a floating point, you can do that very, very easily with DNP3 and bring all of that information in. Okay. I just want you to look at this slide. This slide is going to make more sense for you when I do a couple of examples. But in the utility space, where we're talking about critical infrastructure, whether it's water, wastewater, oil and gas, a gas distribution network, or power, there are several common telemetry protocols that are being used. And these are Modbus, DNP3, and then the IEC 870 and IEC 61850. Modbus has been around the longest. It is the most common even today, but it lacks a number of features that the critical infrastructure systems need. DNP3 and IEC 870 answered this about 25 plus years ago. Why DNP3 has become more popular is because other utilities have adapted this to become pretty much a de facto standard in many places like UK and in Australia, parts of the Middle East, for example, and now more and more authorities here in the United States. They're incorporating it because of all of the advantages that the protocol has. And that's fundamentally tied to the timestamping, the data classification, the push and pull, and the security aspect of it. And the newest kid on the block is IEC 62850. It's still very much in the power industry. And the biggest reason why somebody uses IEC 61850 today in the power industry is the way it addresses the objects. So that makes it very simple and very easy to use. But if you look at the features, and if you, let's say, for example, if you focus on the difference between DNP3 and Modbus, you will see how the advantages of DNP3 come into play, especially with today, where everything is connected. We're talking about Industry 4.0 and IIoT. And if you think about any of those things, the underlying factor to be successful in an IIoT implementation or in this connected enterprise, 4.0 is data. You've got the connectivity part as well, but it is data. And without that data, you cannot achieve it. What DNP3 allows you to do is to get that data back more reliably, more securely through authentication, which then helps you with things like predictive maintenance, reducing your mean time to repair, making data available more easily within the organization, and really that even though time-stamped, you're still able to analyze the data in near as real time as possible and then provide feedback to improve the efficiency and the productivity of the system. So I wanted to give you an example of why DNP3, when I say that there is no holes in your data, and you're going to see here with this example of what I mean with that. So this is a traditional Modbus system where you've got a Modbus SCADA master that's pulling an outstation. So let's say it pulls the outstation at 10:30 and 20 seconds. So 10:30.20 seconds. And it says, what's the status of the pump? And if you look at the time, it's past that, so it returns a status to say that the pump is off. Now, it pulls 5 minutes apart, so at 10:35:20, the master initiates another pull to the outstation, asking again, what is the status of the pump? And this time, if you look at the time, it would return that the pump station is on, that the pump is running. So in between these 5 minutes, the pump has gone on and off a couple of times. You don't know about that. So if you're trending, for example, what is this pump doing? You're basically going to see these two markers, and for the time in between, you're going to see a flat line. So that's not an accurate picture. That does not help you with things. So for example, let's talk about predictive maintenance. Let's say the manufacturer says you need to maintain the pump after it has been started 20 times. If you're not capturing that data accurately, well, then you will not be able to maintain that pump correctly, which means it then reduces the life of that pump. That then has a negative impact on your operational costs. So if you're spending more money to maintain the asset, it impacts the bottom line negatively. So, which is why I say having that data, the most up-to-date, accurate data is very, very important. Same thing if you take DNP3, for example. With DNP3, let's say we do the same poll at 10:30, and we're doing a class 0. And remember, class 0 was for static data, real-time data. When you do that, what you get back from the pump station is just not one value, but you get all of the data that is class 0. So you're going to get back to say that the pump is off, plus all of the diagnostics information, like the number of times the pump is started, how many hours the pump is run, and all of that information. Then let's say we do an event poll 5 minutes later at the same time, so 10:35:20. Excuse me. So in this case, when you do an event poll, you're going to get back all of the status information to say the pump went on and off at all of these different times, plus all of this additional data that comes back. So now you have a significantly more accurate picture from that side to say, okay, my pump did go on and off several times. Do I need to investigate? Is that normal? Is that an alarm condition? Should I investigate? Do I need to bring forward the maintenance on the pump. So these are all of the things that you can do when you have reliable data from the remote site. Okay. Right. So if you look at the use cases, and we've kind of already gone through that, but I just wanted to throw these diagrams up here. Again, DNP3 is used in utilities, which is critical infrastructure, whether you're talking a water or a wastewater system, which, by the way, ProSoft has got a number of solutions for these applications. Contact your local distributor or the RSM. So if you're looking for connectivity or wireless solutions, protocol conversion, they're all in there. But where DNP3 plays a play is in the communications of sending this data back from these remote assets back into the central location. And it's exactly the same whether you're talking about a well pad or an oil and gas type application, or whether you're talking about a power application where you've got sort of remote pole top substations, transformer tap control, these different kinds of sites that all need to get their data back to the central monitoring and location. And they use DNP3 because of many of the features that we spoke about, the push and pull and the timestamp data and the security and all of that. So we've kind of covered an overview. I've given an overview of the protocol, all of the advantages of the protocol, and how it applies to the solution. So let's actually look at the product that ProSoft has that supports DNP3. And the ProSoft product, the solution is called a PLX51-DNPS, meaning it's a slave gateway. We do have the master version coming, and that will be available in 2021. As with all of our products, if you go to a website, it is very user-friendly. You have all of the information in there, whether you're looking for manuals, whether you're looking for the configuration software, which is free, by the way, whether you're looking for frequently asked questions, the data sheet, architecture diagrams, you're all available on our website that you can go ahead and you can download. And customers wanting to use this gateway, they really need to have at least a basic understanding of what DNP3 is, and also understand some of the other industrial protocols, including Modbus and Ethernet IP. So if you look at the product in more detail, this is very feature rich. We spoke about the advantages of the protocol and how it helps with critical infrastructure monitoring, the data reliability and security. You have to take that and say, okay, does the ProSoft solution, yes, it's using DNP3, and I understand the advantages of the DNP3, but what does this do as a product for me? For example, does it support, has it got multiple types of communications? Does it support, is it easy to diagnose? Is it easy to configure? So from that perspective, when we look at those features, this is very, very feature rich. So if you look at the product itself, there's a there are two Ethernet ports, which you can either use as a 2-port unmanaged switch, or if it's a Rockwell-based system, you can use it as a DLR or as a device level ring. It supports multiple protocols. So these would be downstream protocols, meaning communicating to the controllers, which would then be converted to DNP3 by the gateway and then pushed up to the top end. That would typically be DNP3. There's a USB port. Today, it's restricted to only controlling to connecting to compact logics or control logics processors, but we're looking at feature enhancements for that. There's an onboard web server in the module for diagnostics that tells you how the module is working, the events on board and so forth. But one of the big advantages of this product is the support for secure authentication v5, which is the current release standard. It ensures end-to-end authentication. We're going to talk about that in a bit more detail and how that works. You've got diagnostics, LED diagnostics as a serial port. So it does support both DNP3 serial and DNP3 Ethernet. It's got a micro SD card, which is for diagnostics. One of the things I mentioned is reducing the mean time to repair. So with the micro SD card, what you're able to do is to store the configuration and the firmware in it. So let's say, for example, the module fails, then all you have to do for the technician is they've got to take a new module out of the shelf, install it, take the SD card from the existing module, plug it into the new one, and it will then allow them to get the module up and running very, very quickly. So they don't need to be an expert. They don't need to have their PC. They can simply replace the module, plug in the SD card, and then the module will start operating. Another really cool feature as an engineer that I love is a protocol analyzer. So, for those of you who commission or are systems engineers, I think one of the worst things is being stuck in a factory and trying to understand why two machines are not working. You think the wiring is right, you think you've got all of the settings correct, but the two machines are not talking to each other. And because it is all bits and bytes, you can put things like Wireshark or other like an RS-232 breakout box and check, but that requires you to interpret all of that data. The onboard protocol analyzer does that. So it shows you the bits and bytes, but the coolest thing is it converts that information to English so you can actually understand it. So you can see, is it transmitting the message? Is it receiving the message? Is it sending it to the right destination? Is it coming from the right location? Which is very, very useful. And I think there's a couple of screenshots that's coming up that you can see that in a bit more detail. I mentioned about authentication. I think it's very important to understand that there is a difference between encryption and authentication. Encryption, which is very common in IT, is where data is all garbled. Your zeros and ones are all mixed up, and you can't really understand it, and it has to be decrypted when it gets to its destination. Authentication, on the other hand, is more about convincing the other party to say who you are, to be who you say you are. So the example I like to use is, let's say, for example, if you've got a cousin or you've got your family members that come and knock on the door, and you might say, look, I don't like salespeople knocking on my door, so I'm going to give my family a secret code. And that person might come and knock on the door and say, hey, I'm your brother. And you might say, okay, that's good. What's the secret code? So you know who it is, but if they don't tell you what the secret code is, you're not going to let them in. And that way, then, if a salesperson comes in and say, I'm your brother, but they don't know the code, you don't have to let them in. Secure authentication is based on the standard 1815-2010. Certainly because we support secure authentication v5, the SCADA system has to support it, but this is the current standard, which is fantastic. The advantages of secure authentication: it works on any network. Encryption is IP-based. You've got end-to-end authentication, which is good. And I think the other big advantage with authentication is you reduce the risk of any unintended actions, like by accidentally turning on a pump, because when you do a control action, it is a two-stage process to say, do this, is this what you want me to do? You get the verification, and then you kind of go ahead and you do it. So if you look at it and how to work, basically this is kind of the flow that I just explained, where if you're trying to turn on something, then the station says, yep, got it, I can do it, but you need to verify who you are, who you say who you are, before I can actually perform the action. So these are some acronyms that you will come across. Some of these are related to North America, but they are used globally, so you might see them. And the key here is that we will, with Secure Authentication v5, we can help with some of that compliance. And basically, we've got you covered because our solution is very, very secure. So, you might think, wow, this product has got all of these different features. Is it really complicated to use? And the answer to that is no. It's actually very simple to use. The software, like I said, can be downloaded from our website for free. It is configuration. There's no programming involved. There's no scripting involved. To set up the gateway itself is all clicks. It's all configuration. So it is super simple to set up. And you can actually see a lot of the diagnostics features and so forth come into play. Here's a screenshot of the protocol analyzer, where you can actually see the bits and bytes, but you can also see that the information has been decoded to say that is it a response, is it a read, is it a send, who is the destination and who is the source. So you've got all of this information that helps you diagnose any problems that you've got very, very quickly. And then, of course, the web server as well. The module can be added to the I/O logics tree as a standard Ethernet module. Once you've done that, then you're able to import the configuration. So that makes this very, very easy to use with the Rockwell system. It certainly is very optimized for Rockwell. You've got access to all of the data structures. You can see all of the data very easily. So it is, in a nutshell, this is a very simple module to use. Just to reiterate, there's no scripting, it's all configuration. Obviously, it works in tandem with the controller, the PLC, which is where you've got all of your logic, but the DNP3 gateway routes the messages. It converts the incoming through to DNP3 and then handles the communications through the top end. These are some example architecture diagrams. So if you want to use it sort of in a DLR type routine, you can do that. With this, idea being that if you lose one connection, then you can get to the gateway through the other side, and that way you still have access to the gateway in terms of communications. The USB port, so today it only supports connectivity to control or compact logic controllers. So this shows you can certainly connect to Modbus devices either with serial or with Ethernet, and then have DNP3 master back to the top end. You can also have a single gateway that can talk to multiple controllers. It can do that as long as all of the controllers are communicating via the same protocol. So it can be Ethernet or it can be Modbus. It cannot be either or, but you can have up to 3 controllers connected to one gateway. So again, that then helps you with reducing the cost of the solution. Okay, so this is pretty much a summary slide. So they said that the gateway enables intelligent routing between DNP3 and Ethernet IP or Modbus protocols. The gateway itself, it's super flexible and it's very easy to configure. It does support secure authentication. There is an onboard web server for diagnostics and also an SD card that allows you to reduce your mean time to repair. It certainly is optimized for Rockwell architectures, but it does not mean that it only works with Rockwell. It will work with any controller out there. And remember that DNP3 itself is an open protocol. So the idea is that we communicate to the controllers either using Ethernet, IP, or Modbus. We would then convert that data to DNP3 for communications back to the top end. It supports different types of connectivity, and it also supports both the Modbus and the Ethernet protocols for downstream communications. And with this solution, as we spoke earlier on with critical infrastructure, whether it's water, wastewater, oil and gas, what's most critical to them is reliable data that they can get access to in a very secure manner. The data has to be accurate, it has to be reliable. And with the DNP3 protocol and the ProSoft solution, which is the PLX51 DNPS gateway, customers can capture data with no holes. So again, a big advantage where you've got a communications failure, and then this would ensure that because data is getting logged, you can get that data back all the way to the top end. The ability to time and date stamp at the source. One of the key advantages of the protocol is that it does support time stamping natively. And then, of course, being able to get alarm conditions into the SCADA master quickly when you compare to, say, a traditional Modbus type system where it is sort of in a round robin type polling routine where it's continuously going around and asking for information, which means then when there's an alarm condition, you could be missing that. So with that, I'm going to stop and then I'm going to open up for questions. Feel free to use the Q&A window to send in your question. And then, like I said, either me or my colleagues can answer them. So here's a question that's come in. And the question is, It is asking, let me go back a slide so you can actually see the product image. So the question that came in is, how many events can be stored in the module? So that's a good question. That information is there in our data sheet, but this module can store 900,000 events. So what that means is this module can store, with a date and a timestamp, 900,000 events that's happening at the remote site. So, for example, if your pump changes state, goes to on and off, let's just take that as a simple example. It can store that for all that time. And now it is limited to 100,000 of each type. So in the case of this pump going on and off, it can store that 100,000 times, for example. But then let's say, for example, at the same site, you've got a tank level, or you've got, a temperature reading that you want to record, a pressure reading, then that's another 100,000 it can store. So it stores 100,000 of different types of objects to a total of 900,000 events. So there's another question that's come in which says, does the product include the USB cable? Again, another good question. No, it does not. That's available as an accessory, but fundamentally also because if you've got a logic sort of compact controller, many customers have already got that. So it is not included as part of the package. Another question that's come in is, it says if secure authentication will work with radios. The answer to that is yes. Remember that authentication is different to encryption. And one of the advantages that authentication offers is it will work over any communications media. So if you've got a 1200 baud radio link, or you've got a 900 baud, a 9600 baud radio link, or a high-speed radio, authentication will work on any of those. So here's another question that's come in. It's asked about the price. I would recommend that you connect with your local ProSoft distributor or your regional ProSoft sales manager, and they can provide you with the required pricing information. So here's another question that's come in, and that asks that if I have two SCADA masters at the top end, can the DNP3 S gateway communicate to both? So the answer to that is yes. What you would need is actually the SCADA master that would go and talk to the gateway requesting the information. But as a slave gateway, it will initiate the unsolicited message to the primary SCADA master. So an unsolicited message is where the outstation recognizes that there is an issue, the pump has gone faulty, or the pressure is high, or the temperature is high. It then sees that the alarm condition is satisfied. It then initiates a message to the top end SCADA to say, I've got an alarm, you need to come and get the information. There's another question that's come in to say, does the timestamp include milliseconds? The answer to that is yes, it does include milliseconds, yes. So some good questions coming in there. Looks like there are no more questions. So if there are no more questions, then I can end the call. Or like I said, we do have some more minutes to go through. Feel free to send your comment in through the chat window. If you want me to either go back through another section, or if you want me to explain something else, let me know. Otherwise, I will wait for a few more seconds and then go ahead to finish the call. Okay, so it looks like there are no more questions. So thank you all for your time. I really appreciate it. Once again, remember that this call is being recorded. So we will make this recording available to everybody that registered. So they will be sent out over the next few days along with a copy of the slides. Again, thank you all for your time. Stay safe. Have a wonderful day, a wonderful afternoon. And I look forward to talking to you all soon. Thanks for now.